Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at applying our knowledge of transformations to polynomial graphs. So I've listed all of the transformations there for you. Now, sometimes you will need to apply multiple transformations to a graph. So we need to do it in this order. Once again, we're going to do what's in the brackets first, then multiplication, then addition. So in the brackets is horizontal shift. We'll do that first. Then dilations and reflections, because we're multiplying a number out the front here. Multiplication comes after brackets and addition comes last. So we will do the vertical shift last. All right, let's look at this graph here, which is the graph of y equals x cubed. I'm going to use this to draw the graph of y equals negative 2x minus 1 cubed plus 4. So there are quite a few transformations here. We are shifting 1 to the right because of this negative 1. That's this translation here. Then what we need to do is dilate it 2 units vertically. So here k is greater than 1, so it's going to be a stretch. Then because of this negative here out the front, we're going to reflect it about the x-axis. And finally, this plus 4 means we're going to translate it up by 4 units. So we have to perform those transformations to each point on this graph. So as I said in a previous video, let's just look for clear points and transform them and then join them up. So let's look at this point here, which is the point negative 1, negative 1. So I'm going to perform those transformations in order. So I'm going to move it 1 to the right, which will move it up here. Now then it's been dilated 2 units. That means because it's 1 unit below the x-axis, I will double that. It'll now be here, 2 units below the x-axis. But that negative out the front means that the third transformation is I have to reflect about the x-axis. So it's going to go from negative 2 here to positive 2 up there. And then the final transformation was moving it up 4 units. So it's going to move up here to x equals 6. So what about this stationary inflection point here? We're going to do the same. We're going to move it 1 to the right because of the negative 1. Now, if I then dilate this, because it's on the x-axis, it's going to stay this. Doubling a distance of 0 from the x-axis is still a distance of 0. So after the dilation, it stays here. Now I need to reflect about the x-axis, but this point will still stay here because it's on the x-axis. But the final transformation was shifting it up 4 units. So it's going to go up here at y equals 4. That is the new location of the stationary inflection point. And then the last point I'll move is this point here at 1, 1. Let's do the same thing. It's going to move 1 to the right. So it's now 1 unit above the x-axis. So a dilation of 2, a vertical dilation of 2 is going to move it. So it's now 2 units above the x-axis. So we've doubled the distance from the x-axis. Now we need to reflect about the x-axis. So from y equals 2, we're going to go down here to y equals negative 2. But the final translation is up 4 units. So we're going to move it back up here to this point 2, 2. So now we can see what the graph's going to look like. Because it's been reflected, it's going to go like that, stationary inflection point, and go like that. And then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.